Hi guys, good morning. Welcome back to the new video. So basically, in an apartment, the light has not been coming in since last few hours, and I have been using everything at max. Still, like you see this light on, it's actually with the UPS which we have got. So not sure how long it will work. Maybe stream will happen, maybe not. God knows. But yeah, let's quickly see this problem. It's a very good problem, including XYZ plus XYZ. You will get to know that both XYZs. But yeah, let's start with the itself. Smallest sufficient team. So basically, you have a project and you have some of the required skills, which in total you need to get all the required skills. When it means like you are a captain and you need to get all these required skills. Now, what you can do is you can have people in your team, and basically ith person has some of these skills which he has. So basically it's basically an array of strings just saying that okay, that people of I has some of these skills. Now ultimately you need to make a sufficient team, and that sufficient team should be such that you take some people and accumulatively they all should have all the in total you should have all the required skills which you need, and it should be the smallest possible size of the team which you have to make, considering the fact that all the people accumulatively should have all the required skills in total, right? Basically every required skills in the required skills, it should be at least once in the team which you form out of all these persons, right? Cool. For example, if I make a team with 0, 1 and 3, it's just the indexes representing the people of 0, people of 1 and people of 3. Cool. So ultimately I have to return any sufficient team of the smallest possible size representing the index of each person. Cool. Now ultimately, as we look at the example itself, we will just get to see one thing. Okay, I have some required skills which I want ultimately in my team. Ultimately, I have the people where every person, okay, the first person have the skill as Java, next person has the skill as Node.js, next person has skill as both Node.js and React.js. So one thing very easily comes in my mind is, okay, we need the smallest possible size of team, right? So why not I think of, okay, I will just grab that person who has the maximum skills. Usually in an interview, it happens like this only, right? If we have 8 people, then if you know, okay, this one person has maximum skills, so firstly grab this maximum skill person. So basically I know, okay, my Node.js and my React.js is done. I have got a person who can give me this Node.js and React.js, and it is 2 skills which he can give me. So remaining 1 skill, I can get Java from 1 person. Cool. By this I can think of, okay, let's choose to think greedily, and by that maybe our answer is possible. So what we are thinking is initially thinking of as, okay, and that greedy is very intuitional. Okay, it might come as greedy, but what you are doing in greedy is you are just saying, okay, choose the person with maximum skills and then try to bring in those persons who can actually give the remaining skills possible. But whenever you are thinking of greedy, either validate that, okay, greedy is true, or validate that greedy is never true. Usually what I do is I go opposite way. I just validate, okay, greedy will not be possible. I will prove greedy will not be possible. If I cannot prove that greedy is not possible, then I will say, okay, greedy can be there. But just to simply go in the reverse way, greedy cannot be possible, what I can do is simply make a greedy example. I will take a person with the maximum skills, and I will try to make an example such that he's never been taken. For example, I will take the person has skills as A, B, C, D, and other person has skill as F, other person skill as F, E and F. So if I choose greedily, I will choose this person, then I have to choose E and F also. So basically, if I want all these skills as A, B, C, D, E and F, so I'll choose these 3 people if I choose greedily. But if I don't, then I can easily choose these 2 people, and also they can give me my example. So for sure I can get to know that greedy won't work. So I have to try for all the possibilities. When I say all the possibilities, I have to go and ask for everyone, who can I take and who cannot. Basically, maybe this person I can take, this I cannot, this I can take, this I cannot. So as I was just looking at the example itself to try on all the possibilities, I get to know that for every person I have 2 options. Either I can take that person or I can ignore that person. Basically not take that person in my team at all. Again, a simple thing of 0 1 knapsack comes in picture, take that person or don't take that person. It's a very standard thing. So now one thing for sure, you know one thing, okay, you will make the recursion or you will make something as either you can have bottom up or you can have top down, your wish, but yeah, you can make something as a recursion, and for sure you have to memorize it because ultimately you know that it will have repeating sub problems. If you don't, then please go and watch EP Intuition playlist by Aryan Mittal. Just write that on YouTube and you will just get that intuition playlist of DP and you can just go through it. In that we have from scratch told, okay, how to get this intuition, all that stuff. But yeah, now you know it's a take it, not take it. Simply, you know, you have to write either a recursion, usually we go via recursion, but yeah, in this example, top down, sorry, bottom up is actually very easy to write, but still, many people don't understand bottom up as very intuitional. That's the reason I will specifically teach you top down and then I will actually show you the bottom up as well. But yeah, it's actually very helpful if you go via the bottom approach in this question. Cool. Coming back to, we have two options, take it, not take it. Now, simply if I take it, take what? Take the skills. Now, what I mean is take the skills. Skills for every person I have some strings. So basically for every person I have a list of strings. Okay, for every person this list of strings, which means this list of skills he has. So what I want is, in total, I have some required skills. At max it can be 16 required skills, and for every person I will have some skill. So now to actually bring in, okay, how I can use those people's skills, because I want to take the skills. Now either I can use the entire string again and again. No, I can basically hash it down to something. Okay, I will take this skill, I will not take this skill, which means ultimately now what I wanted was take these skills. Now ultimately I have to, and skills is a string, so I have to transform this string into something very short and concise that I can use in my problem again and again, because I know I will be taking these skills, a set of skills again and again. Now when it comes to a set of skills, and we know that those set of skills are not very much, it's very less, it's just 16. So for sure I can make kind of a mask, which means a binary thing that, okay, every skill can be represented by a 1 or a 0, which means 1, that skill is taken, 0, that skill is not taken. So for sure I can transform this set of skills into actually mask, or basically a binary number in the form of skills. What I mean by that is, let's say the required skills are Java, Node.js and React.js. I can easily say that as, okay, let's represent it as a 1 1 1, where 1 1 1 is in the binary form, 1 1 1 actually representing 1 2 4, which is actually a number 7. So ultimately this number 7 just says me, okay, I have got all these skills. Or you can also say this as, okay, the people as basically Java. If the people is having, the person 1 is having only the skill as Java, for sure you will say, okay, it is just one Java, so you can just simply say a 1 0 0, only Java he has, right? Although while if we just go on later, you will see that, okay, I will take it as an indexing of 0 1 and 2, which means indexing 0. So I will represent this Java as a 0 0 1, this Node.js as a 0 1 0, this React.js as a 1 0 0. 1 0 0, right? But yeah, for right now, for just to show, okay, how this actually can work, is just, okay, Java, a simple 1 0 0 will work. Will just say me, okay, I have Java in place. This Node.js, okay, 1 here, 0 0 here. Just say me, okay, Node.js is in place. Node.js and React.js, okay, Node.js, React.js, and just Java is 0. Just say me, okay, it is actually in place. Now, with what will help me is, I can just easily, by this number itself, I can get to know what skills this person has, and I don't have to go on the entire strings, right? That is how I can easily get. Now see, we just got, okay, how to take the skills. This is what we got to know, that, okay, we can use bit manipulation to actually get the skills out of every person. Cool. Now we have got these skills. Cool. We have got the skills. Now actually the work will start for us. How? If you have got these skills, firstly, you know, okay, how logically you will make the mask, but let's see that how you will make the mask, and then we will just simply go on that, okay, how take it and not take it would actually work in for us. For sure, as we spoke that, okay, for Java we need to make a mask of something as 1 0 0, something like that, right? Now for this, what we need to have is, we need to know, okay, at what index was it in skill required skills, because if it is an index 0, you will left shift this by no 0. If it is at index 1, you will left shift that by index 1. So basically I am representing every of those skills in its binary form. It is as 1, it is as 1 0, it is as 1 0 0. But now to represent that, I have just a number 1. How many left shifts I should do, I can just simply know by indexing. So I have to firstly place indexes for every string. So what I will do is I will go and place indexes for every string, which means for Java index is 0, for Node.js index is 1, for React.js index is 2. That is, you will see in this problem, I made a map called as skills, which is from the string to int, mapping for every skill what is the index, map for every skill what is the index. I just mapped it down. Now after mapping this down, I would know, okay, for this skill Node.js, the index is 1. Node.js, the index is 1. If the index is 1, please left shift this 1 by 1 time to get the actual, this particular thing. Okay, I will left shift this by 1 time, get a 1 0. Now it is actually representing me the actual for this particular Node.js. For this person 2, it's a person, let's say person 0, it's a person 1. For the person 1, the actual skill set he has is 1 0, representing a 2. Representing a 2, which means representing, okay, he has just Node.js. For example, if the person at the index 2 have skills as Node.js, I will go and ask, what is the index of Node.js? Index of Node.js is actually a 1, which means I can represent this as a 1 0. By just left shifting this by 1 time. Index of React.js is actually a 2. So I will just represent this like index React.js as a 1 0 0. Now I know, okay, both of this skill is with the person with index 2. So I can just simply do an OR operation to get, okay, he has both the skills. So I simply do the OR operation to get a 1 0 0. And I can simply represent this as a number to just say, okay, this person at index 0 has a skill 1 0 1 1 0, representing 1 2 1, representing a 6, representing, okay, he has both Node.js and React.js. That is how I can simply transform just this whole list of strings to actually just one number saying, okay, he has this string. Cool. By this you can simply know, okay, you just went on to the skills of every people, for every person, you just went on to the skills he has, which means for every person you went on to Node.js and React.js. You got the index by just simply going to skills of skill, which you put in here. Now as you have got the index, you will just left shift with this by left shift 1 by index times to actually get this particular mask. As you have got all the masks, just simply do an OR operation with all of such strings for that person, and to get the simple final number h, and that h will be representing the skill for that person I, right? Now, okay, you have got for every person what is the skill he has in just one number, representing, okay, this person has his skill right here. Coming back to what we ultimately want that we need to choose such out of all the people, let's say after all the people, I need to choose some people. Ultimately what they should do is they should give me all the required skills which I wanted. So I will just simply say that my required mask, my ultimately required mask is simply getting all these skills. And when I say all these skills, it just simply mean getting a 1 1 1, which means if I have required skills as 3 skills ultimately required, so I can make a mask as 2 raised to the power 3 minus 1, which is nothing but a 8 minus 1, which is nothing but a number 7, representing all the skills are required. So I just simply made a mask saying, okay, 1 1 1 1 n times will just say me all the skills are required for me. Now ultimately I will just go and do my simple recursion, making a solve function. Firstly, what we know, we have to go at every person, so for sure index would be required for us, and ultimately at every person when I'm going, I need to fill in my skills. For that skill I have to make a mask, because ultimately you know everything is going in the mask terms. So for sure I need to make a mask. Initially I have no skills with me, which means, see, when I'll grab any skill, I will just populate my mask with those particular ones which will just say me, okay, at any place if it is a 1, he has that skill. Cool. So I'll just simply say right now I have no skill at all, because I'm starting with nothing, so my mask is a 0, representing I have no skill at all. Cool. Now you will just see what it is this, but it's an initialization of my DB and my array as choice. We'll see what this choice is, but yeah, Simply, let's go on to actually the recursive part. Now, as we go into recursive part, the first thing which we look at it is the recursive case. As we look at the recursive case, firstly, as we go on to every index, I have two options: either take that person or ignore that person. Now, if I include that ith person, what will happen to the mask? Firstly, if I take that ith person, and then I can simply move on to the next I plus 1th person. But if I take the ith person, what will happen is the mask will get populated with the values of that particular person's skill. So basically, if I include the ith person, so the people of I will have the skill of people of I, right? This ith person's skill will be in the people of I, right? People of I, and my mask is having, okay, in total what I have skills got so far. Initially it was skills as 0. If I do an OR operation, so for sure the mask will get populated with the skills of people of I. So I can just simply populate the skills of people of I with my particular person, and I can simply get, okay, he has done this. But as I've included one person, so please simply add a 1 because you have included one person with you. What if I just ignore this person? So simply, if you ignore this person, you move on to the next person, and for sure your mask will remain same because you have not added any skill, because you have ignored that person, you have ignored his skills. That's bad. Cool. Now it is two options. Ultimately, what you wanted was take the minimum. Take the minimum, because ultimately you want the minimum. If you remembered, you want the minimum possible size, and what you are doing here is you're populating your size itself. You know, okay, you added a 1, which means you added in the size. Initially your size was 0, you added a 1 because you took one person and you want to take minimum possible person. So for sure you will take the minimum possible person. Now again, we'll look at it later because it is just one addition of what we ultimately want. You remember, we don't want the size, we don't want the minimum size of my particular team. We want all the people in that team, right? Also, so ultimately here we are getting the minimum size of the team, which is, okay, it is the smallest possible size of team. But ultimately this question is asking, okay, smallest possible size is 4, but what all people are there? That also we need to take. We will look at it later, but yeah, ultimately it is what we are returning. But you should remember at the back of mind what you actually have to return. Going back to the base case, what will happen is as soon as your mask will reach the required mask, which means the current mask will have the skills, if you have reached all the required skills, simply return a 0 because you are good. Because why we are returning a 0? Because we are adding something, and for sure we are adding something and taking the minimum. So for sure please add something which is simply minimum, and it should not affect your answer. If your I has reached the end of all the people's person, which means all the people's have exhausted, simply return a large value, but not very large, because you know you are adding something. So for sure return a very large value, but not int max that, okay, it should exceed, it should not overflow, but yeah, like return a simple large value because it should not. Because if I is there and you have not reached the mask, which means never you will be able to achieve it. So simply, if never you will be able to achieve it, simply return a maximum value. It is a base case, done. Simple memorization which you do in a simple DP, initialize, it is by address. So it's the reason I have just simply referred it as answer, although you can just put it as a DP of mask or I mask or whatever you want. But yeah, remember it's an address. That's the reason you are initializing and returning in actual DP itself and not the variable itself. Please remember that. So it's just an initialization of DP. It's just a call of DP before actually calling the recursive function. So simply done in there. Now, although you have got what is the minimum possible size of your team, but you needed the person itself. So for sure you need to keep track if that person, that ith person was taken or not. So simply, if you get to know, okay, if you choose this ith person, and for sure if you're getting the minimum possible size, which means that ith person is a good person, he's contributing in a better way. So if this answer 1 is less than my answer 2, which means taking the ith person is actually helping me in getting the lower answer. So please, if you choose the ith person, then please mark, okay, take an array and say, okay, if I choose this ith person, it will be, just say, okay, choosing that ith person is actually a 1, which means it's actually good to choose that ith person. And this mask will simply say, okay, at that point of time, which means at that point, choosing this ith person was actually beneficial for me. So I'll just simply say, okay, it is a 1. It's just how my DP is also initialized and my simply must also initialized here. Now you have solved your actual recursive functions. Now coming back to actually the main functions, you know that you have solved, you just call have the recursive function, but this recursive function will return what? It will simply return the minimum possible size. But I wanted something which is actually stored in my choice, which means that every person is required or not. So what I will do is I simply go on in my people's array, which means to actually go on to every choice, that okay, if that person should actually be taken or not. So I will just simply initialize my answer variable, and I will simply go on my entire people and will say me, was it good to actually choose that person or not? If it is 1, it was good to choose that person. So I will just simply choose that ith person, which means I will simply push in that ith index of that person in my answer variable. And if it was good, then simply also populate the mask with the skills of that person, because you know ultimately in recursion you was populating with the mask of that ith person. So simply make it with that, and ultimately I will just keep on repeating this until I have got all the required skills which I wanted, and I will simply break from this point and I can simply return my answer. By this you will simply know that okay, your answer will have actually the indexes of all the possible people which can actually contribute in getting all the skills and in the minimum possible way, which means the minimum possible people required. Now coming back to the code, you can just simply go and see the code. The code is pasted here, entire code. The time we actually people into 2 of skills, you know it is nothing but you just went on to every people and for sure you made a kind of a mask, right? So that is for 2 skills, which is the mask which you made. And same goes for the space, as you know that you are just simply using initializing a DP and a choice variable. But I can for sure optimize my space as it can be done in a simple questions of DP. But for that you need to go to the bottom up approach. Exactly same here on here also in the top approach you saw, I was going on to every of the person, and that at every person I'm just asking him if he can contribute in my actual any value or not, right? If he cannot, simply go on. If he can, simply see the contribution. Same I will do it in my bottom approach as well. I will just simply go and ask him, and for sure if the people are understanding okay what this two skills means, simply getting okay, if the skills are in total 5, then this thing will actually give me all the possible cases. If I just say okay, I have 3 skills, now what all possible cases it can be? Just take no skills, just take this skill, which means the skill at the number 2, just skill at the number 1, skill at the number 3, and so on and so forth. So it will just say me all the possible options of skill combinations I can take. With this 2 skills, I can just choose all the possible combinations of skills I can take. So ultimately just repeating the same stuff as we did in the bottom up. Simply firstly what we will do, simply initialization of my DP, right? It's very simple. Now as we did the same stuff, which means we need to map our required skills to actually indexes. We did the same stuff, mapping the required skills indexes to actually its actual skills. Now for sure you need to know that okay, for every person you need to go back and convert that person's list of strings to actually a number. So I will just simply go back and ask for okay, what is the actual index of that skill, and there's just a simple left shift and there's a simple OR operation as we saw earlier, exactly same, making the skills as a number for every person. So I just get it for every person. Now as we simply go on in the bottom up, simply go on to every person. So I just simply I just simply go on to every person. I just simply go on to every person, and then for that person, although you can just initialize this before also, but yeah, it won't matter because ultimately you have to go at every person also. So I just go on to every person. Now for every person I have got his current skill, what he has in a form of a number, by just simply doing a binary bit manipulation operation. Now for every person I need to know the contribution of him in all the possible options of skill, right? And what all possible options of skills we have? A 2 skills option which we have. It will just say me all the possible combinations of this skills which I can have. So this person can contribute in what all these options. I will just see the contribution of this person, right? So for this one person, I will see the contribution in the entire DP, and you know that the entire DP is initialized by a 2 to the power n, which is the skills. Now, as I know, okay, for this person, what's the contribution? I will just see what is the combined skill, which means for this DP, it will just say that, okay, my current skill is, let's say, for this, okay, if it is a 2 to the power skills number of possible options, so it will just say right now, let's say the current state of skills is 01101, right? Now he will just say, the person will come and say, okay, I can contribute the skill as 101. So what I can do is simply doing an OR operation by simply getting, okay, if the existing skills is combined with his person of I skills, it is the existing skills, which is a initially DP, which we have. If I can just simply get to know, okay, what is the new skill he can get is a 01101, or I can simply say, okay, if it is a 1 or 0, so it can just simply get a 01111. So just saying, okay, if the skills is combined of this person with the existing skills, now the new skills which can be formed is actually this 011111, right? I will just get the combined skills. Now I will just simply ask my DP, shall I update you, DP bhaiya? Shall I update you? So he will just say, okay, if I am not even in my DP, if the combined skill is not even in the DP, for sure, update me. If it is in the DP, and for sure, the size of it, and what you mean by the size, he will keep track of all the indexes. He will keep track, the size will give me basically the list, basically this DP of combined, or this DP of any particular skill. He will just keep track of what all people were there who could contribute that skill, and I will just keep on optimizing it, which means I will keep on making this whole thing as smaller and smaller. Now right now it is 4, but I will just keep on trying to make it smaller and smaller. So you know that ultimately, if your existing whole size, if it is more than 1 plus your existing DP plus 1, and why I'm doing it, because I know my new size of DP will become this. Why this? Because it is the existing DP size, which is this particular whole size of DP, and one I am adding by myself, which means one person I'm adding, and he will just say me, okay, what all person he had, I will add one person. So the new size will actually be becoming 1 plus DP of I first. It is a pointer which will just say me, okay, it's because you know it's a pointer, or begins a pointer, so it will just say me, okay, if this new size, if it is less than actually the existing size, so please update the new size. So I'll just simply go and update the new size, simply getting the DP and getting the new particular person in my DP itself, so as to get the new person. And ultimately you need to require all these skills. So just go and ask the DP of all these skills. All these skills is 2 to the power n minus 1, as I showed you earlier also, that how this thing works, that for this ultimately -1 is just giving me all the skills which is required, and for sure we are storing in DP all the indexes of all the people which are required, same as above what we saw, right? Same time complexity, but it's just that the space we are actually optimized, because we are just manually iterating on all the people, and for all the people I'm seeing the impact on just my skills. So for sure I don't need to keep track of the people itself in that, and that's how you can simply solve the bottom approach as well. Although it's a bit for the starting phases, it's a bit hard to actually start off with the bottom up straight, but as you keep on going, it can become a bit easier. It was a clean code, so that is actually can be much helpful. The code will be down below for your reference as well. No worries on that part, but yeah, that was above the top down approach, which is actually much more intuitional for you guys. So I hope that you guys, okay, bye bye. I hope that you guys like it. See you guys in the next video. Until then, goodbye, take care, bye bye. That is what I say. Bye.